Good evening. Welcome to this video lecture on construction and working of a BLDC motor. In our day-to-day life, we use fan. We use a ceiling fan. And most often, ceiling fan is the only appliance which is constantly used for a longer duration. And if that fan, if it happens to be an energy efficient fan, it is a boom to us, right? Do you know what type of motor is installed in such energy efficient fan? Right? We will just see it. Right? It is none other than brushless DC motor. Brushless DC motor is also a type of a synchronous motor. Just because the word DC is there, it is not a DC motor. It is a synchronous motor. It is a type of synchronous motor where the magnetic field generated by the stator and the rotor revolve at the same frequency. And in normal DC motor, it is commutated motor, right? Electrically commutated motor. But here it is electronically commutated motor. So we call it as brushless DC motor. Like any other machine, it has got a stator and a rotor, right? We know the stator structure, it could be a slotless or it could be a slotted, right? If it is going to be a slotless, the inductance value is going to be very high and it can be very well used for high speed operation. And because of the absence of the teeth arrangement, the cocking torque also in the machine is going to be very low, right? That's the advantage of using a slotless stator. And if you go with the type of BLDC based on the stator winding arrangement, you can classify it. It could be a single phase or it could be a three phase. It means that we can have a single phase winding or we can have a three phase winding in it. If you go with the rotor arrangement, it can be divided based on the placement of the rotor. That is, if the rotor is placed on the surface of the center periphery, then we call it as a surface mounted structure. If it is going to be embedded inside, right, it is going to be embedded inside, then we call it as a embedded rotor arrangement. Or you can insert the rotor between the core also. That is also possible. Based on this placement of the magnet only, you're going to have two broad classification. That is outside, okay, or inside. That is, it could be if your magnets are placed inside, it could be called as in runner. If the magnets are placed outside, we call it as out runner. The magnets, most often we use electromagnets, but permanent magnets also it is possible. Three types of permanent magnets are possible in BLDC: neodymium, iron boron, samarium cobalt. And these magnets, if you take up the magnetic property, they have high coercivity and high permeability also. When the coercivity is very high, automatically the torque value also it is going to be very high. Okay, right? So we can have high torque with what to say with smaller size itself. We can have high torque. That is, the volume of the product can be very less with high torque. And coming to the commutation, the main part of the machine, we place three sensors for the electronic commutation. And that is what you see here in the figure, right? You see three blue color locations. So that is where the Hall sensors are placed to know the rotor position. And the whole commutation is done electronically. So we use a driver circuit, or we can call it as an inverter circuit. So each arm of the inverter has got two devices, right, or two switching devices. So if one switching device conducts, automatically the other one doesn't conduct. And we have the commutation taking place in a sequence. So based on like here you can find a table, commutation table. Based on the location of the hall sensor, the phases can be switched on, right? So if the hall sensor, all the three hall sensor positions are taken, and if you have it as 0, 1, 0, phase 1, the upper switch is turned on, and phase B, lower switch is turned on. It means that we operate two phases at a sequence, and the other phase is going to be turned off completely. And for every 60 degrees, you have a particular switching sequence being followed. This switching sequence, it depends on the direction of rotation also. Suppose if we change the direction of like rotation, automatically the sequence also it changes. And the type of commutation that you are going to have, or the waveform across the winding, it is going to be a trapezoidal, right? It is going to be in trapezoidal shape. So we call it as a trapezoidal commutation. So six sequences of conduction takes place in one magnetic cycle, and this magnetic cycle gets repeated sequentially. And if you compare brushed DC motor with brushless DC motor, you have more advantages in brushless DC motor. The life of the machine is going to be longer. It requires very less because it has got more electronic parts than a mechanical part. Like the maintenance is going to be very less. And speed torque characteristic also, it is going to be flat. You're going to have very high efficiency. Output power of the machine also, it is going to be very high. And you have only permanent magnets, you don't have winding in the rotor. Automatically the rotor inertia is going to be very low, so the machine can be operated at very high speed. So the control, the main issue is with the control. So the six sequences of commutation, that has to be done properly, then you're going to have it as a like easy one, right? So, and the machine is going to be quite expensive compared to the normal DC machine. That's the main thing with a brushless DC machine. So whatever I have told you, that it gets covered in the advantages as well as in the disadvantages. So where do we use all this brushless DC motor? We can very well use it for tractive application as well as for non-tractive application. If it is going to be a tractive application, the best example is your electric vehicle, right? Two-wheeler or a four-wheeler electric vehicle is the best example. When it comes to non-tractive, we can take the example of a CD drive, then all the robotic applications, robotic arms, then the CNC operation, then the fan, pumps, blowers, right? Wherever there is a torque demand, high torque demand is there, you can very well use this particular BLDC motor. Right? See whether you can take up this assessment. If you are able to take up this assessment, it means, right, this video will help you to learn the construction and the working of a BLDC motor. Right? Keep learning, grow with learning. Thank you.